The human brain is an amazing product of evolution, often seen as one of the most complex structures in the universe. It's made up of about 86 billion neurons or nerve cells, and each is connected to about 1,000 others, creating over 1 trillion connections on average. It works in ways we don't yet fully understand, with far more memory and recall capacity than any computer yet developed. All this runs on the equivalent of 20 watts of power to function. Imagine if we could harness that incredibly efficient brain computing power to run the AI systems of the future. I'm in Vevey in Switzerland to meet some scientists who are trying to do just that. Switzerland is a hub for brain research, and here, near Lake Geneva, is the HQ of Final Spark, a company working in the new field of biocomputing, also known as wetware.
Hello, how are you?
The founders, Dr. Fred Jordan and Dr. Martin Cutter, already run a successful anti-counterfeiting company, which holds over 80 patents.
Fred and I, we were always really motivated by robotics and artificial intelligence, and that's something we wanted to do for a very long time. And we started by doing artificial intelligence the standard way. Neural networks, we created programs that wrote programs, and it was really exciting. But each time we added a new server, we had to add a new air conditioning. So it was really complicated and expensive, and we said, that's not the way to go. And so one day we said, let's try to use human neurons. The question was, how can we get those? And we started working with universities in Switzerland, and we realized that today it's possible to create neurons using stem cells.
Stem cells are specialized self-renewing human cells that are able to develop into many different cell types. This can range from muscle cells to brain cells such as neurons. Can you take me through some simple steps of how we go from stem cell to organoid?
You apply a specific protocol and you're able to transform a skin cell into a stem cell. Once you have a stem cell, there is another protocol with chemicals and temperature and time that allows you to transform this stem cell into a pluripotent neuron. So basically you can make neurons out of it. And then after some time you get real neurons, and you can get different types of neurons, like in the human brain. And once you have those, you put them in a shaker, an orbital shaker. It's like a big bath which is moving. And the neurons, they stick together and they start to connect. And as soon as they connect, they start to get active and they communicate with each other. And so you have mini balls of neurons which are active, which live, and you start to use them by using them on an electronic chip.